Look, I'm just a geologist. I like rocks. I love rocks.
Hey, good evening, everybody. Good morning. This is the Geology Flannelcast. My name is Steve.
Hey, I'm Chris.
And I am Jesse.
Welcome.
Yeah.
Today is another exciting episode with just the lonely three of us.
Oh, Eeyore.
We're taking it back to our roots.
We are.
That's it. It's just hanging out, hanging out with the boys,
Exactly. Not to say that we're not going to ever have guests on again, but we're gonna charge for it, something like that. No, I'm kidding.
Anyway, we have people on. We're just. Well, you can charge people. See what that does to our numbers. All right. See how that works out.
We lost both of our listeners.
Oh man, no. Well, this is not. We're not doing a live episode today. Today's a pre-recorded day, just kind of a little easier. Summertime, just kind of
it's
relaxing.
the middle of the summer. We're not trying to. People are doing things. We're taking it easy.
Yeah.
But because even when we take it easy, we still want to talk geology.
Well, we're not dead. Let's face it. It could be in the middle of a snowstorm, a heat wave, a global pandemic. We're still going to want to talk about rocks.
There you go.
That's why a lot of people don't hang out with us anymore.
That might have something to do with it. I don't know.
Let's keep the lights on here. Let's pay some bills.
Yeah.
Have any of you had to tackle, Chris? You had to do some work for school today, or for your job today. Did it happen to be in Word, perhaps?
It's just emails today. Sorry. I mean, yeah.
I set him up and he just crushes me.
This is like the last episode or so when you were trying to lead me. And I was like, no, what? No.
Anyway,
but if I did require some formatting on like Microsoft Word, you betcha I would have contacted the formatting formula.
Thank you very much, buddy. Yes. Or we can go to youtube.com/C/formatting formula. Again, we talk about this every week. So I'm just, sometimes I feel like I'm beating a dead horse, but at other times I feel like I'm not saying enough, because they really do a great job with all of your word formatting needs. Like really oddball, weird stuff that I didn't even know you could do with Word. They can figure it out. So hundreds of hours of videos, I think, for both Mac and PC, walk you through the scenarios. And because it's on YouTube too, like they do it at a great, nice pace. But if you have to pause, try it, see if it works, hit play, go back to the video. It really does work very, very well. So I can't say enough about the formatting formula for all of your Word formatting document needs. Check them out. youtube.com/formatting formula or formattingformula.com. But the most important part of all this is make sure you tell them to Geology Flannelcast sent you. Otherwise, they're going to leave us forever. And then we'll be stuck here doing this podcast in the dark. Because the formatting formula pays for our electric bills.
Wouldn't be able to turn the computers on.
No, you'd have to charge them in your car and then bring them back inside. Come on, man. I've thought this through.
Oh, the solar panels. I see what you're saying.
Yeah.
You have some solar panel car?
No, like this, like you have like the layout. Ever see like the expeditions when they go like Antarctica or something? They have like all the solar panels they lay out.
No, Chris drives one of those like engineering department like speed solar cars. That's like the size of a bicycle.
Something like that.
Yeah. Well, Atlanta's good for something. It's a lot of sun.
It's pretty rainy down here. You'd be surprised.
Oh.
You're like,
so Atlanta's good for nothing. Never mind.
I mean, Coca-Cola, Home Depot.
I will give you Coca-Cola. Yeah.
CNN.
I like CNN.
I don't mind CNN. I don't mind Home Depot either. Actually, you hit three pretty big ones.
I'm a Lowe's man.
I'm a Lowe's man myself, but
I didn't even know Home Depot was out of Atlanta.
Oh
I
yeah,
didn't know that
Delta's
either.
out of Atlanta too.
Yeah, I don't know.
Weather Channel,
I love the Weather Channel. Grew up with the
all
Weather.
the Turner channels, Cartoon Network.
Yeah.
Anyways,
Well, he started CNN, so that makes
yeah.
Mhm. Yeah. What has Philly done? Just
Started the
democracy.
country.
liberty. I don't, yeah. What more do you want?
Yeah. What have you
Uh,
done for me lately?
Throwing snowballs at Santa Claus in the 70s.
we
Yeah.
should. We
He was
we should-
drunk.
should.
He deserved to be thrown snowballs at.
We should take the first, not this part, the first few seconds and send it off to the Atlanta Tourism Bureau. Maybe they'll sponsor us.
Ooh.
And they're like, no, you're just literally naming things. You're not really selling it.
Yeah.
Yeah. Well, great.
Yeah.
All right. So we figured today we just kind of talk about some more kind of current events and kind of just go off on some tangents about what's going on in what's in the news and kind of go off on kind of, I don't know, that stuff.
Yeah.
Yeah. Should you guys want me to start off first? You're good.
I was actually thinking about this today. Yes, I do want you to start first, but I have this will be my Jesse's Corner, is a PSA here. I was thinking about this. If any of y'all out there, I know we say always send us questions. If you have questions, send us questions because we'll eventually answer them. But if you see, and I'm going to get better about this, when I see all these news stories, and we joke about how many tabs I keep open on my phone or on my computer.
Yes.
In the hundreds.
It makes
But every time
making
I
my
see-
skin crawl right now.
Every
Carry
time
on.
I see a story, like I keep it open and I see a lot. I'm going to start posting those links. I'm going to get all of our passwords for all of our social media.
You have them all. I've told.
Yeah, I know, but it's a sieve. It's a
Yeah.
sieve.
All right. So what are you going to do? Because this is
you
news
gonna
to all of us right now. So this is
You're going to tell the password to us on the air.
Yeah.
nope.
Open
Nope.
to the public. No, but so I'm going to try and be more proactive about, because I think it's interesting. We cover 1/10 of all the stuff we see, but if you see an interesting story and you want us to talk about it, pass it along. I'd love it.
Post a link.
Yeah, post it if you're. We're on all the social media garbage, Facebook, Twitter, Instagram. Shoot us.
We're not on Instagram.
I'm going to set up an Instagram. That's what I'll do.
We did have one set up.
I think we did have one set up.
Definitely didn't revive it when we revived this podcast.
No.
Yeah.
I'll set up one, or we'll reset the password. And I was thinking, I was like, we do field work. We could take pictures or whatnot, but we're shut in right now. So I'm going to go up into my attic and dig out my rock collection.
Cool.
I put it away when I had kids because I didn't want them to eat them.
Were they like the size of Skittles? My rock collection's big rocks. Like what?
Yeah, no, I got big and small. I don't. What was once our office turned into a nursery, and now is a kid's bedroom.
Yeah.
And so got boxed up and put away. But I'm gonna dig it out. Maybe like every day, I'll take a picture of one and do a little write-up about it.
Ooh.
Hey, what's your
I don't remember
favorite?
what rock this is.
Yeah, what's your favorite rock in your rock collection? This is great
Anthracite
for them.
coal. Yeah.
Really?
Yep.
Wow.
Yep.
This guy loves coal. If you go through the backlog of Flannelcast episodes, he's always talking about how much he loves coal. He loves this.
Oh no, I know that. He just had that answer right away.
I know, boom. He knows. Guaranteed. I mean, like we all know what our favorite rock is, but he was just boom. That's it. That's like Steve. What's your favorite rock in your rock collection?
It's probably garnet. I have a big.
Oh, big! Wow,
garnet. It's like
yeah,
halfway between a golf ball and a baseball.
Uh-huh.
It was from the Barton Mines.
Oh, up in New York.
Yeah.
Oh, cool. I got a big slab of sandstone about the size of I don't know. It's probably about a foot and a half long. It's like a dinner plate slab. It's probably even bigger than a dinner plate, but it's got this beautiful cross bedding in it, and I kind of have it on display in my living room. I like that one.
That is a good one.
Yeah. Well, it's just like so hard to find a good sample, like a good hand sample of cross-bedded sandstone. Because you really need a bigger. It takes up. You need like a wider swath to see the cross-bedding. But this is I got this from Kentucky, down at the Red River Gorge. Oh, was that the garnet?
Ooh, that is a nice looking garnet. Darn it.
Oh, wow.
Yeah, and it's heavy, man. This thing's dense.
Yeah, it's I got some from the what's it, Gore Mount or the Adirondacks, where they have the biggest garnets in the world.
Well, that's the Barton Mine is up in Gore Mountain.
Oh, I was at the Barton Mine then. Yeah, I was there. Yeah, okay.
Temple University used to have a building called Barton Hall that was named after that family. Like they donated the money to.
It's from them?
Yeah.
Oh, I didn't know that.
Yeah.
Oh, how about that?
It is now.
It's a
whole
ground.
Some library. Charles. Chuck.
The Chuck
D. Library.
Yeah. So I wonder, like, you donate money and you get a building named after you, and then like 30 years later they tear the building down. You kind of, if there are any relatives, like, hey, you're gonna rename something.
Yo,
else?
buddy. Yeah.
That's a good question.
You know what we should do right now? I wonder if we could pull this off. We should have a contest. I'm to it. I'm announcing a contest right now. Here we go. Just off. This is totally.
This is how we do it.
This is improv off the top of my head.
We're really shooting from the hips here.
Tweet us at Flannelcast or hit us up on Facebook and send us a picture of your favorite rock from your rock collection.
Ooh, I like it.
We'll take a couple of the ones we like the most, and we'll announce some winners, and we'll send you some stickers and stuff like that, a little prize package.
I like it.
Yeah, we'll put it up on the so let me take a note of that. We'll do that. There you go. Spur of the moment contest here at the Geology Flannel.
If you really want to butter us up, actually send us the rock.
Ooh, yeah.
I don't want your rocks. Just send it to Jesse.
We
got
a
one-bedroom apartment. I can't take any more rocks.
There's a good story of like when I moved out. I lived with my brother, and when I moved out, he helped me move. And he picked up this box, and it was like super. He's like, "What is in this? Just rocks?" It was totally a box of rocks, and he's like, I don't know what I expected.
Well, speaking of Jesse's brother,
I was just going to say that. Speaking of your brother, there is
an edition of the controversy of the summer of 1992, ladies and gentlemen. There was a turning point today.
Yeah, so
a breakthrough, perhaps.
We had a new Facebook friend, a listener who says he said he got a chuckle out of it. He calls himself a junior geologist too because he's an anthropologist. But first of all, he sent you a nice picture of a cover of a book called The Ash Warriors, which is about Mount Pinatubo. Then he sent us a nice link about the Pennsylvania weather. And, I hope your brother's listening because Pennsylvania weather book, 1991, hot and dry. Then it just skips 92 and it goes 1993, hot and muggy. And then the first line in 1993 is, after a cool summer in 1992 that was mainly attributed to the eruption of Mount Pinatubo in the Philippines.
So I got some points here. GW sending us that message on Facebook really got my back.
So I think the official score now is Ryan 4, Jesse 2.
I like it.
I mean,
Ryan, where are you at, man? Come at us. Well, not come at us. Jesse, I didn't do nothing. All right.
Yeah. So thank you very much for those Facebook posts. We look forward to them. We love them. Some people post just say, hey, thanks. Great show. Some posts like, hey, you got this little thing wrong or that little thing wrong. And we love that too. Like we're not looking for trolls, but we're striving to be as correct as possible. So keep them coming, please.
Yeah. So we got another email about a correction. We can talk about this for a minute. Let me pull this up here.
I'd rather not.
Rather not?
No, I'm joking.
Oh, I don't like the way you said it. I assume.
Oh no!
What are you doing, idiot?
It's too late now.
All right, so we got an email from our friend Dan, and he goes, "Just wanted to issue a brief correction on the evolution of grass before 2005, grass was understood to have evolved about 55 million years ago. But in a couple of studies published that year, phytoliths were reported in Cretaceous coprolites. So, okay, so if you are a junior geologist out there, let's break down some vocabulary words in here. Phytoliths are these little, it's like a grain of quartz. That's what it is, right? Inside grass, or grass secretes silica, right?
Yeah, it's a minute piece of I guess silica.
Yeah, and it's a tiny little grain of silica, and so that's what it is. That's what a phytolith is. And they report it in Cretaceous coprolites, and coprolites is basically fossilized poop. Not basically, that's exactly what it is. It's fossilized poop. So, and he sent over some papers. Sent over 2 papers from back in 2005 about this. So, so so I know we talked a little bit about some potentially some what else that could be, right? So basically they're saying that grass in about 55 million years ago, grass really became widespread. But then there is some hint at it, like smaller patches of grass evolving during the Cretaceous. Is that correct?
Wait.
Yes.
Yeah.
Well, so if you think about it, like the way things evolve on the planet, you don't have, grass in Kentucky one day and then grass across the whole planet the next day. It evolves over time. The habitat has to be right. All these other things. So there is some evidence of these pockets in other places earlier than 55 million years ago.
Yeah, I think you see like some early evidence of rice-like things. Rice is a grass. Back as I want to say the Aptian or the Albion. So right.
So that's in the Cretaceous period. Yeah.
It'd be interesting. I should look into this. There's a lot of people not a lot of people, but one of the lines of evidence in terms of looking at evolution of plants, and especially like flowering plants, would be, and that's a grass technically it falls under a flower. It's an angiosperm. Looking at actually the genetics, and they're doing sort of genetic work on some of this early stuff. It'd be interesting to see. Interesting being subjective.
How do you have any genetic material remaining after 100 million years?
I'll get back to you next week.
I mean, we've all seen Jurassic Park.
Watched it tonight, actually.
Really?
Yeah.
With the kids?
Yep, showed it to them first time.
Did they freak out?
No, not at all. They were. I forgot about this. The first half of it, the first hour is just like people talking, and they were pretty bored.
Yeah. But then that first T-Rex scene hits where the lights go out.
I think they were lulled into. They kept asking when it's going to get exciting, and then it finally happened, and they weren't terribly scared. Although when the lawyer, spoiler, when the lawyer gets eaten off the toilet and he's like bit in half, Evelyn, my daughter, looks at me and she's like, "Is he dead?" And I was like, "I think so, buddy."
Yeah, he gone.
Yeah.
But to her credit, the first time I saw it, I was like, "Wait, what just happened? Did he really just get eaten in half?" Like it goes by real fast. So
yeah. So, but yeah, they can do. I mean, you can extract like lipids and other sort of biomarker and bioinformation from rock. So
I guess it just needs to be preserved in the right conditions.
Yeah, I don't. I'll look into it because I've got all the time in the world. Nothing to do.
No, I believe it's possible. It's just
back when I was
incredible. That's all.
Yeah, well, back when half the reason I know about this is when I was studying the pollen, I set up some Google alerts, and like every week I'll get a rundown of like papers that cite things or new article alerts about some new flower or some nonsense. I never read them. I've only got so much brain power, and I just can't do it. I usually
saying
choose like
but time.
Yeah. I was being facetious.
All right.
But I do like I wake up and it's like 6:30 or 7 in the morning. I roll over and I have like a Google alert because there's like a new pollen study, and I was like, no, that's not how I want to wake up. That's not.
Come on, man! Wake up call for pollen studies. I can't think of a better way to get woken up.
Tell me something. Yeah. Anyhow.
I gotta call out my buddy Victor on this podcast. He's probably like losing his mind right now, but he said he saw that we were doing the live stream the other day, and he goes, "Oh, this is great! I'm like super excited. You guys are doing the live stream. I've been having problems sleeping lately, and this is great."
That's hurtful.
Yeah, that cuts me deep.
So this will be the test to see if he's listening or not to the podcast.
Oh man, no, he's asleep already.
He's asleep.
He wasn't hearing it. He's hearing us in his sleep. Maybe he's having dreams about this now. You know, like
I have some weird non-geologist friends too, and they're like, "Oh, that podcast thing, like you're doing that again?" I was like, "Yeah, man, we have 183,000 downloads." They're like, "Oh, wait, what?" Like, yeah, people listen to this, and hopefully not just to fall asleep. Maybe we're like the #1 insomnia podcast.
Maybe that's what it is. Yeah.
Yeah.
Study centers, they just play our podcast.
We need to do like maybe people just like our rhythmic voices. I'm going to start rubbing rocks together and do some sort of weird ASMR spin off of this podcast.
Oh yeah.
So anyhow, I guess everyone's asleep. We should probably just wrap this episode up.
All right, let's. Do you want to do a news story, Jesse, or do you want me to jump into this?
I'll do the first one.
All right,
and then I can go to sleep. It'll be great.
All right.
So the first one I've got is sort of interesting. I'm not sure I fully understand what they're talking about.
This is always a great way to start this off. So.
Yeah. So there's a group of researchers that were looking at basically really old felsic rocks, so continental crust, continental rock, like 3 billion year old rock.
Okay. So we're talking original craton stuff?
Yeah. And I want to say from, so they sourced it from, some of it's from Siberia and some of it's from Africa. South Africa. So craton stuff. So shield, like where you find the shield. So shield, if you don't know, is like
really the OG crust, basically.
Yeah, really stable, old continental crust.
Oh, I thought it was a Marvel movie.
So they use this sort of novel, I guess it's novel approach to look at iron and zinc isotopes. Obligatory GOTOPes.
First Simpsons reference of the day.
Yeah. And so what they basically found was by using these isotopes, you expect a certain ratio of these isotopes if you're deriving your continental crust from either partial melting. So when an ocean plate subducts, as it's subducting under, it dewaters and degasses because it starts to heat up, and so all of the water and all of the gas percolates up through the overriding plate. So whatever plate is above it, and when you get that gas and water bubbling up, it actually lowers the melting point of that overlying rock, and it causes parts of that overlying rock to melt. And the parts that melt are felsic. They're lower temperature rocks. So felsic rocks are lower density. They make up the continents. And so one of the thoughts is for continental formation is that you have, if you have an ocean plate subducting under another ocean plate, the subducting plate dewaters, degasses, and it's going to melt the overlying plate, but it's only going to melt sort of the felsic part of it. And that felsic rock comes up to the surface, and now you have this low density chunk of rock that won't subduct anymore. So that's one idea about sort of where the continents come from, and then over time,
no matter what happens, it's just too light to get sucked under.
And then over time, you get these little continental islands crashing into each other, and they weld together. You get pieces of the oceanic crust that subducts under a continent that scrapes off, and so you have these welded on pieces where you have really high metamorphism going on. That help continents grow as well. So that's where your continents come from. And so that process of partial melting or metamorphism from the collisions is expected to produce, or I guess you do see, a certain ratio of these iron and zinc isotopes. But these researchers looking at this really old cratonic rock, so 3.5 billion year old rock, you don't see that ratio. And there, apparently this ratio is basically it doesn't change by you don't
weathering or anything.
Yeah. And so the thought is that these early continents or this early plate tectonics operated differently than we know it to operate today. There's so it's sort of, it's the continents weren't formed by maybe subduction as we previously thought.
So
some sort of entirely different process.
Yeah, I guess I'm a little ignorant as to how the first continents formed. Are they saying originally it was just oceanic crust and then it started subducting on each other? And then, and then you get that little bit of a light blob and then boom. Continental crust.
So there's two sort of thoughts, I guess. And if you know anything about this, jump in. Is that, after the Earth starts cooling down, it's all oceanic crust, and then for whatever reason, plate tectonics starts. And we have no firm grasp on when plate tectonics starts. That's all.
We still don't even know what the true mechanism is.
Yeah.
So,
but there's also some thought when things solidified, you did have areas where you had lighter elements, sort of.
Kind of just differentiation, just like the layers of the Earth.
The whole entire Earth is just separated by density.
Yeah, but sure. No, it is. I agree.
It is, but I'm guessing with it, the rapid cooling at the surface may have mitigated some of that differentiation.
I don't know enough about it to really step in and say one way or the other.
I know during during the Archean eon in Precambrian time, they say that's, I think is the middle or end of the Archean. Anyways, let's just say during the Archean, 85% of the continents that we know of today had formed. 85% of the I guess the surface area of the continents that we have today had formed. And then when you go into the Proterozoic, still in Precambrian time, I think by middle Proterozoic, another 10% had formed. So
the Archean and the Proterozoic, they're billions of years apart, aren't they?
I mean, it's all. From the beginning of the Archean to the end of the Proterozoic, that's billions of years. Yeah, the Proterozoic itself is like 2 billion years.
Right. I have a problem differentiating this often because you have that standard geologic time scale, and it's like here's the Precambrian, here's the Mesozoic.
Yeah.
Well,
and they're all like this.
Yeah,
but this represents
Goliath compared to everything else. Yeah,
exactly. That's what I mean. So when you say it in this third of this geologic timescale map, that's not really a third of all geologic time.
No, that's what I'm not saying that.
Yeah, no, that's all. I just wanted to say it. Yes, 85 to 95% of all the continents were formed by this time, but that did take a while to do.
Oh, I see what you're saying. I see. Yeah, I see what you're saying. Yeah.
Yes.
Yeah, that's a good point. I mean, like I make that mistake a lot. Just we tend as geologists tend to forget about Precambrian time. It's a crap load of time. It's most of
4
billion years of time right there. Like that's a lot of time. So yeah, I see your point, Steve. And yes, I agree with your point.
But that isotope thing is interesting. But at the same time, I feel like there's got to be some variables that were just different, other than plate tectonics, that may contribute to those isotopes.
Yeah, I mean, your whole redox state of iron,
right?
At the time, there's no free oxygen. So, but I think they're saying like redox doesn't play a role in it. So I don't know.
Yeah, I just don't know that much about iron or zinc isotopes to figure out like what causes it, like what causes it to go from one iron to a different iron, or one zinc to a different zinc. I don't know. So yeah, it'd be interesting reading. If anybody who's listening knows more about it, please let us know.
Yeah, I might dive into it. So it's research that came out. It was an article in Geology, came out at the end of June. So so it's legitimate.
Fairly topical. It's about a week old. So yeah, very cool. Nice article.
Yeah, thank you. I'd like to bring the information. That's what they say about me. This guy brings the info.
Hey, this guy just complains about the info.
No, it's good. You should always question. That's what we talked about, right?
Mm-hmm.
Yeah.
There we are. All right. Well, after Chris sneezes.
Yeah, Chris is having some sort of
a little bit of cough there. Excuse me. All right, so I got a story. Let's talk about the moon. You guys know anything about the moon?
Nope.
Nothing. I heard it's like it's made of cheese or something like that, and I don't know.
I knew the cow jumped over the moon.
Ooh.
Good night, moon. Good night, cow who jumped over the moon.
Steve, how memorized do you have that book? 3 kids now.
If you asked me 2 years ago, I probably could have read you the whole thing without even looking at it. But
good night, nobody. Good night, bowl full of mush.
Yes. Good night, creepy old woman whispering hush.
Yeah, just sitting there in the dark.
Yeah, it's really weird.
Wow.
That book was written in like the 30s or something too.
Was it really? I don't know anything. I mean, I don't have any kids. I don't know. I just know.
Well, maybe that'll be a Patreon episode where we'll just read that to you. Speaking of putting you to bed.
Yeah. They're really doing a good job right now.
Yeah. There's a I say children's book. There's a children's book called Go the F to Sleep. And it's like a joke book for parents, but Samuel L. Jackson read it.
Oh, yes.
On like YouTube. It's hysterical. It's like, I know you just want one more story, but go to sleep. So, yeah.
So I got a new story about the formation of the moon, gentlemen. We all know the moon. You can see it on nice clear nights and its beautiful craters.
It was just full.
Was okay.
Yeah, I think it was called something. It had a goofy name too, like the beast.
Oh, there was a lunar eclipse on the 4th of July. I thought I heard.
Oh, yeah, I think you're right.
Yeah, I picked my niece up from work last night at like 11:30, and there's all these people standing in their cars in the parking lot. Like, what are they doing? And they're like, oh, they're taking pictures of the moon. Apparently, it was super pretty. I don't know. Yeah,
on the 4th of July, we were walking over to watch some illegal fireworks. No, they're illegal now, fireworks. And it was like bright orange. It was really cool.
Yeah, it was really orange. Yeah, down in Atlanta too.
It's currently raining.
So there's been I've always been fascinated by how how scientists have studied the formation of the moon, because it's not like, you can just take a weekend trip out there. It's extremely expensive. And I think they're saying they're going to go back to the moon in 2024. But we'll see. We'll see how that works out. But so there's a new study that was done on the moon using remote sensing. And so that's how we get most of right now, it's all of the information. We haven't been back to the moon since in a very, very long time.
Yeah,
70s, right?
1974, I want to say.
Apollo 17.
Yeah. I want to say, Apollo 17. Eugene Cernan was the last man on the moon. And, he was there sometime in the 70s. I was trying to look it up quick, but I didn't get any answer.
All right. So,
does anybody know about Apollo 18?
Oh, wasn't there a horror movie about that?
It was a They Might Be Giants album in the late 90s.
Wow.
Yeah, that's right.
I did see there was like a horror movie where like there was an Apollo 18, but like, I don't know, moon goblins.
Ooh.
Sounds about right. All right.
Yeah.
So
1972, actually. So we
72.
literally landed on the moon in 69, went there for 3 years, and then just stopped going.
Yeah.
Real bummer.
So now we have one of the tools that we use to study what's going on the moon is NASA has a satellite. It's called the Lunar Reconnaissance Orbiter. And so what they do is they can use remote sensing to figure out if this one, they were looking at different dielectric properties inside the craters. So metals, things that are metallic, are going to have a very distinct dielectric property to it, a very distinct dielectric value. I'm getting too much into the nitty gritty. They can figure out where the metals are. Let's just leave it at that. All right. And so they're looking at this and they're finding that there's a lot of metal, specifically iron and titanium oxides, that are at the bottom of these deeper craters. And so what the thought is that when objects strike the moon, you get these impacts hitting the moon. The impact brings up stuff from deeper in the moon's crust, and it's kind of giving you a snapshot of what's under the ground at the moon. And so they're looking at why they're really intrigued by this concentration of these iron oxide. There's a higher concentration of iron oxides than what we have on Earth. And the thought was that when the moon formed, originally the hypothesis is that there was like a planet-like body, is approximately the size of Mars, named Theia. That smacks into it collides with the Earth. The Earth is 50 million years old, and it ejects a portion of the Earth's crust, and I believe a portion of the mantle too, right? Or is it just the crust?
No, I think it
was the mantle too.
The mantle. Okay, yeah. So it ejects that out, outside of the Earth, and all that debris kind of collects over time, and that's what it kind of coalesces, and that's how the moon formed. So the thought is that if the moon is if it's a part of Earth, then it should have the same chemical signature as the Earth does. But now they're saying, now that they're finding out that this data from the bottom of the craters is showing that underground, like under the surface of the moon, there's a lot more iron. And so now it's just like, what the heck is going on here? So basically, this greater concentration of metal deposits in these deeper craters could suggest other hypotheses on how the moon formed. And so it's worth taking a look now at. Maybe we're not 100% correct. Maybe there's other factors at play.
Yeah, that's interesting.
Yeah,
I think we need to send a drill rig up to the moon is what we need.
Yeah, for practice in case an asteroid ever comes close.
Well, that's true too. If Armageddon has taught me anything.
Now I want to know, what are the iron and zinc isotopes like?
Didn't say anything about the iron. Oh, it just said the iron ox. Didn't say anything about isotopes.
No,
Sorry,
I
man.
know. Full circle to my
Yeah,
So-
from our last article.
So, anyways, one other thing is they're saying, I forgot to mention this. If they're finding this much of these of the iron oxides at the bottom of these craters, this collision when Theia slams into Earth might have released a much deeper section of the Earth and might have put that into orbit. And this thing could have occurred when Earth was still young and covered by magma oceans as well.
Oh,
True, and we also don't know what the makeup of Theia was.
Well, that's what I've always wondered. Yeah, because they talk about, and that's just, I don't know, it might just be my ignorance on the subject. This isn't my field of study, anywhere close to my field of study, but you would think that whatever that planet body that smacks into the Earth was made of would be in the moon as well. And that's just one thing I never really understood about this about the makeup of the moon.
yeah. I was always fairly confused on that.
Yeah.
So,
That's really interesting.
yeah, so it's always cool. Like some of these studies, I'm always amazed by the amount of data that they can interpret and then extrapolate from just looking at iron oxide concentrations at the bottom, at the base of these deep craters, and what that means. Like, isn't that always amazes me that they can
Yeah,
just
and it's
take
essentially
one
just fancy pictures. Like they're just multi-spectral pictures that they're taking of the moon. And now we're extrapolating about how it formed.
Yeah. That to me is always like the coolest thing, I guess. Yeah.
I like the moon. That's my takeaway.
It's
Big
nice
fan.
just to
Big
stare at it on a nice summer night, just laying out. And,
I was I'm going to interrupt your story.
I'm done with my story. You're gosh.
Getting very poetic about the moon here. I like to lay in the dewy grass and stuff on a warm night. Shoot, I read something like 2 or 3 weeks ago about the moon is slowly leaving us, right?
Yeah.
And in something like 1 trillion years it'll be gone. It's moving very slow.
I don't know about a trillion. I
Yeah.
think it's a couple billion.
No, it's long. It's like, I want to say it's like 90 billion. You
All right.
put that number out. But I remember
You go off of your tangent. I'll fact check this.
okay. I remember like hearing the number or reading the number and being like, what? That's the exact noise I made. I'm a cartoon character.
50 billion years?
How many?
50 billion.
So we're in between. We shot the middle.
Wait a minute. This is saying in about 50 billion years, the moon will stop moving away from us and settle into a nice stable orbit.
What?
It's never leaving.
All right, continue. I'm going to dive into this.
My story is gonna have very poor resolution, and it was basically what would happen if the moon left or if we had no moon.
Mhm.
And I don't remember the outcome, and I'm really upset about it. But man, the past like couple months, my brain has just been a sieve. I'm just I don't remember anything. It's like there's a lot of stuff going on or something.
Yeah, I don't even know why I'm here right now.
Already forgotten. But I do want to come
It's
back.
nice to see you guys, though.
Yeah, I want to say it was something like it would really mess with the oceans, obviously. But there was something about wave height. Like we'd have like crazy waves that wouldn't be kept in check by the gravitational effects of the moon orbiting us. I'll dig that back up. I'll pull open one of the browsers and find that tab, and I will post that link.
You just need to check which browser, which tab, which device. It's like a 30-minute process right there.
Yeah, I just actually opened a browser and there's I've got a science paper about the origins of flowering plants that came out in June.
Nice.
So, pollen is always just pulling me back in. They did DNA sequencing and molecular dating methods. I'll have to read it and figure it out how they
Interesting. Jesse, do you have like a rock polisher going in the background? What is that?
Oh, sorry. That's the laundry. Do you want me to?
No, it's fine. It just would have been cooler if it was a rock polisher.
Yeah, I'm really getting ready for Instagram. Polish up all the rocks.
I ran upstairs in the attic and threw all my rocks in the dryer. I hope this works.
Through the rocks and through some slurry, and
I've never polished rocks ever.
it is
like
loud.
in a rock polisher.
Yeah, it's loud.
I've never done that before. No.
I've obviously cut and polished rocks for thin sections and things like that, but I've never actually taken rocks and bought a rock polisher. And it takes forever from what I hear to polish rocks.
I think you got to do like a week or something like that. I've never done it, but I think it's like
we had one growing up, and I remember we would always we'd have to put it in like the furthest corner of the attic because it was so loud and yeah, it would take. We never actually, I don't think, ever did it successfully because it'd be like a week and they still come out. It would always leak. It would leak like the slurry, and it was just a mess.
Geez.
But I did recently see one like National Geographic or someone was offering when I was like, yes, I should get my kids a rock polisher. So I almost pulled the trigger on it. But they're
what are they, like $100 or so?
yeah, something like that.
Oh yeah. All right. It looks like the moon's going to go away in 50 billion years, but don't worry about it because the sun's going to kill us all in 5 billion years from now. So
That sun is always getting in the way of good time.
yeah. So, yeah. Sorry about that. Let's see. The day of the moon is drifting away at 1 to 2 centimeters a year.
About the rate of how far Europe's leaving us.
Yeah, exactly. Right. That's pretty interesting.
Yeah.
Really, the same. A little bit slower. I mean, like if it's
A tiny bit slower.
the Atlantic Ocean's like opening up at 2 centimeters a year, and the moon is between 1 and 2. So it's
It's funny. I want to say this was like 8 years ago, and if we have any astronomers listening, please chime in and correct me. But my dad was like, "Man, that is the largest I've ever seen the moon," and it was like a full moon. And I was like, "Yeah, it's a pretty big full moon." And he's like, "No, like, my dad's in his 60s now, and he's like, no, that's the biggest I've ever seen it." And I was like, "All right, Dad, like." That's enough Miller Lights for you, like. But
I mean,
but then he like 2 days later, he's like, hands me a newspaper, and he's like, "Look at this article in the Inquirer." Apparently, the moon. It was the closest it had been in like 200,000 years or something, or it's the closest it was going to be in the next 200,000 years.
but
So he was dead on.
I mean, I don't think.
eagle eyes over there.
Yeah, I don't know if you can. There is there's a famous. It's a famous thing about the illusion the moon creates when it's closer to the horizon.
No, and I knew that, and this was just up in the sky, but he swore it was.
It's just like, isn't it just atmospheric distortion that makes it look bigger in the?
No, some of it has to do with
sky?
just perspective too, because you have like actual earthly things in relation to the moon, so it just looks bigger.
Which one's close and which one's far away? Apogee and perigee. Perigee is when it's closest, and apogee is when it's furthest away, right?
Apogee is when it's furthest away, and perigee means it's closest.
No.
Yeah, and the only reason I know those terms, the movie Spies Like Us.
Oh.
They talk about like when the intercontinental ballistic missiles are.
Ah.
Oh, well,
Yeah.
when you have apogee and perigee, it increases your tidal range, or increases increases the tides. You get a bigger tidal range.
Oh yes. So were we just at the perigee or apogee?
I don't know.
Because you said it was close and big.
Well, it's not a 200,000 year cycle.
No. I don't know. I'm trusting Steve's dad to.
Yeah, exactly. I'm trusting the Philadelphia Inquirer.
I'm looking up when.
I mean, there's definitely an eccentricity to the orbit. It's not perfectly circular, so it's not just a perfect spiral getting further and further away from us. Depending on the position of the sun and all the other planets, like there is times when it gets closer.
Yeah, when it's at its perigee, it actually appears. It can appear when it's a supermoon. It can appear 15% bigger and 30% brighter. So that's no joke. That's. I mean, yeah, that's noticeable.
Yeah. All right, let's
move on.
We're getting into some topics here that's kind of
outside of our realm.
A little outside of our realm. Yeah. All right, let's. I got another story. This one's a little easier to explain. All right. Did you guys hear about this pink snow in the Italian Alps right now?
Yes.
And it sounds very good. Very good.
All right, moving on. Next one, since we heard about it already.
There is pink snow right now up in the Italian Alps.
It's on a
there's
bad
pink
stereotype.
algae. You're killing me, Smalls.
Yeah, not going to be easy to edit out when he just keeps interjecting every 30 seconds.
Speaking of which, I've never seen Sandlot.
Oh, huh.
That's not getting
snow.
That's not. Hold on. That's not getting edited out. How have you never seen the Sandlot? Like
I've never seen it. I started it like 3 times. I'm like, this is slow. This is like no. It was a little too.
Ladies and gentlemen, the Geology Flannelcast is down to 2 members now. We had to. Oh my God, jeez. Hercules.
I saw a fun fact yesterday about Babe Ruth. His first home run was in Toronto.
Really?
First home run was in Canada. Yep.
Wow. Nice. There was a. It was like 90 years ago, like yesterday, the first Major League Baseball All-Star game.
Oh.
And Babe Ruth hit a home run in that game.
Oh, that was towards the end of his career then, too.
Yeah, it was in the 30s.
Yeah, he retired in 33, I think.
So, yeah.
Anyway, back to the Alps.
Yeah.
You know,
Pink Alps.
Ty Cobb had more votes for the Baseball Hall of Fame than Babe Ruth did.
Ty Cobb was an awful human being.
Yeah.
Next topic, pink snow. The Alps. Not touching that one with a 30-foot pole.
Yep.
Pink snow in the Alps, ladies and gentlemen. This is a really weird phenomenon. It's caused by algae, and the type of algae makes the snow pink. And you might think, like, oh, that's kind of weird. Like, what does that make a difference? And yes, this makes a difference. We've also seen this algae not only in the Alps, but in Greenland and Antarctica. And it's commonly referred to as watermelon snow.
Ooh.
But, yeah.
Sounds tasty.
Yeah, I wouldn't suggest eating it, but stick with your normal Philadelphia wood ice. Hey.
Yeah. Hey.
I
just don't eat the yellow snow.
Don't eat the yellow snow. That's just great life advice. All right, so this algae is watermelon snow, and this can have an effect on snowmelt. Have you guys, gentlemen, Flannelcasters, ever heard of something called the albedo effect?
Yeah, you say, Nito, take your albedo. I'm pretty sure we talked about this.
Something like that. So there's something called the albedo. We're going to just mute Peterson for the remainder of the episode. Really?
Yes, we know what the albedo effect is.
Trying to keep an academic setting here in this bad seat. Just
I'm gonna have some water.
Okay. While Steve is drinking water, I can finally talk right now. So I'm waiting for him to spit water right in the computer screen. So there's this thing called the albedo effect, all right? And what happens with the albedo effect is darker colors absorb more sunlight and it darker. That's why, like, for example, like in the summertime, black asphalt gets really, really hot because it just absorbs more of the energy from the sun. Whereas things that are lightly colored, like that are white, reflect that right back up. So that's known as the albedo effect. And what ends up happening is that this snow now is pink. It's not white. And so it starts absorbing more of that energy coming from the sun. And it's so scientists are worried that this pink snow is going to increase the melting rate of the snow in the Italian Alps. So they've also seen this stuff happening. So this is on a glacier on the Italian Alps. So it's just one of those things of just kind of the glaciers melting away, which nobody really wants to see happen. But it hasn't happened only in the Italian Alps this year. Alaska saw some pink snow also this year. And then in March, Ukrainian researchers on the Galindes Island off of northern Antarctica also witnessed a similar event. But this stuff, the ice was a little more on the red and bloody side, apparently. So, and then previously, they've also documented some weird green algae blooms on another part of Antarctica. And so they're still kind of looking into how these algae blooms in the snow are going to affect things, but it's it's not really helping things out right now. And then another little fun fact about this: last year in New Zealand, some of the glaciers turned pink as a result of smoke from bushfires in Australia, because ash can play a similar role to the algae. And once again, it'll absorb more heat and melt the snow and ice. And then there you go. You get this excess melting going on. So, pink snow in the Alps and a couple in Antarctica too. Alaska and Antarctica also.
That's crazy.
Yeah. So
now, is the algae coming from the sky, or is the algae in situ? Like, did the article get into that? Like, is the algae already there, but it's warm, so then it blooms, or is it being transported there with the snow that's being deposited?
No, it didn't say where the algae comes from or what causes the algae to grow. So, algae on the Alps.
Yeah, so we're all doomed, it sounds like.
Sounds like this climate change thing might really be happening. Who am I? I'm just a geologist.
Might be.
Just a geologist. I like rocks. I love rocks.
You guys hear about the comet?
Yeah,
It's visible.
Yeah,
with the unaided eye now.
No.
Yeah. I mean, I haven't seen it, but it's called. The name of this comet is. This really rolls off the tongue. Comet C/2020 F3, also known as Neowise.
Neowise. You can see it in the morning at the early light, right before.
That's not going to happen.
There is no. I thought I saw something that you can start to see it at sunset.
That's more likely to happen.
You could see it over Lebanon 2 days ago, just before sunrise. So within this next week, you can see it in the early evening sky.
Cool. Yeah, I'll take a look.
So keep your eyes out for
report back to us.
Let us know. Hey, if you see the comet, take a picture, send it to us.
Ooh, yeah.
On our Facebook.
That technically doesn't count as your favorite rock because it's probably just ice and gas, but
ice is a mineral.
It depends.
What do you mean? If it's naturally, this is naturally made. Like, the ice coming out of my freezer isn't a mineral because I made it. It's not naturally made.
But I thought ice has to be compressed enough to where it actually has a regular crystalline structure.
I was always taught that ice is a mineral because I don't know about the crystalline structure. Why wouldn't it have a regular crystalline structure?
I think it's kind of chaotic, and that's why it kind of That's why ice expands. Most things when they freeze, they contract.
Ice is the weird one. Yeah.
Right.
Yeah.
But I think you can actually compress ice to the point where it actually has a regular internal structure, and therefore then that ice is then considered a mineral. This is what I was taught in undergrad. Maybe somebody was pulling my chain, but
all these little fun facts about the Geology Flannelcast, or about just about geology today, they're just like, oh, you think you know.
I'm making a note here. I'll make that my mission to look up. Is ice a mineral?
Is ice a mineral? Well, so then do you think then comet ice would be considered a mineral?
I guess it depends. Was it compressed enough?
It's really cold. Does that count?
I don't know. It's got to be really cold, right?
Yeah. What's interstellar space is like?
A little chilly out there.
Yeah. It's like negative. What is it? Negative 250. It's right. It's like a couple Kelvin.
Just above Kelvin.
Yeah. 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 There's nothing. There's no gas to hold the heat in. It's
man.
Oh man. Yeah, right around 3 Kelvin. So
I'm seeing all this stuff. I just looked up, is ice a mineral? And I went to the premier podcast is going to the premier geology site, geology.com. According to geology.com, ice is a mineral. A snowflake would be considered a mineral because it forms naturally in Earth's atmosphere. However, an ice cube from a refrigerator would not be.
All right. Well, I am wrong then.
I don't know, but that
mark it down. First time Steve was wrong on this podcast.
Edit it out. Start flipping out. Get rid of that.
We're gonna have our podcast is gonna be 15 minutes long after I finish editing it this week. For those of you who listen to the final product of this podcast, it might seem seamless.
Yeah.
But this podcast would not be considered a mineral because it would be not naturally occurring. It would
No, it's natural.
We've been recording for 3 hours. I don't know what you're talking about, Chris.
All right.
There's no orderly arrangement, though. I think
maybe that's where we fail. Yeah.
All right. I got a fun question from a listener here. Actually, one of our Patreon sponsors, Mark from Salt Lake City. Mark from Salt Lake City asked a really interesting question. I'd like to hear your guys' take on this question. So let's see. Let me see where the question starts. Okay. I read somewhere the Earth will take around 90 billion years to reach 0 degrees Kelvin. He's not sure if that's accurate or not, but anyways, if the planet suddenly lost its atmosphere, and aside from the little hiccup of everyone dying, whoopsies, would the rate at which the core cools increase drastically? Or will the surface help insulate and keep the core relatively warm? What do you guys think? I think personally that the rock is such a poor conductor of heat, and it's such an excellent insulator that just the crust alone would insulate it. It would. I don't think anything would happen. I don't think it would affect the cooling rate of the inside of the Earth.
So I mean, if we think about the temperature, so the core right now is, I don't know, I'm just gonna throw a number out there. Let's say it's like 5,000, 6,000 degrees Celsius, right?
Yeah.
That's like 10 or 11,000 degrees Fahrenheit. And it is cooling off, right? The outer core is slowly solidifying.
Mm-hmm.
And so you're cooling off. The temperature of the Earth right now, the average temperature of the Earth with the atmosphere is like, it depends on who you ask, but it's between 15 and 16 degrees C. So like 60 degrees Fahrenheit, 59 point whatever. Without the atmosphere, the average temperature on the Earth would be 0 Fahrenheit, negative 18 degrees C.
I got I got a question for you about that because initially, I initially would agree with what you're saying, but so think about this now, right? The atmosphere of the Earth is like an insulating blanket, right?
Correct.
And so the part of the Earth that would be facing the sun would just be baking, right? But so that part would be really, really hot.
Mm-hmm.
If there's no atmosphere at all on Earth, right? And the part of the nighttime, at nighttime, the temperatures would plummet and it would be really, really, really cold. But the Earth is spinning around. It's like we're on one of those the spits that cook like your rotisserie chickens or something. Yeah, exactly. So one side of the Earth would always be heating up and it would be really hot, and one side of the Earth would be frigid. What do you think about that?
Yeah, no, it's true. I mean, we can come back to the moon, and the moon is really hot.
And then also, this is how that's the reason that there is ice on Mercury. Mercury doesn't really have an atmosphere at all. Yeah. And so there's no, convection, I guess. That's how things that's why on Earth we can stay in the shade and it's not we're not freezing, right? It's because we have an atmosphere that keeps that heat in.
Yeah.
So on Mercury, around the rims of craters that stay in the shadows, you get ice collecting there. You get a little bit of ice there. They found ice on Mercury because there is no atmosphere on Mercury.
Yeah. Yeah. So basically, if you traveled that essentially sunrise line on Mercury, like half of your body would be on fire and half of your body would be frozen. Now, if Earth would be the same thing, obviously it would be a little less intense because we're not as close to the sun, but half, but yes, the planet is spinning though. So you would warm up half the planet and then cool down half the planet, but it's still spinning. So the average temperature, I think, would be close to zero because you'd be going from it would be like plus 400 down to like minus 200. And I mean, that average.
Yeah, on the moon, daytime temperature is on the moon at the equator. It's like 200 degrees Fahrenheit, and nighttime
So that's close to 100 Celsius.
Yeah,
really, really close to 100 Celsius.
Yeah, it's actually closer to probably 120. It's 250 degrees Fahrenheit, so like 120, and at nighttime it's negative 120, negative 130 Celsius.
Right. So it averages out at like 0 Celsius, which is
okay. So all right, so we got that out of the way, right? But
will that 12 hours affect?
Will that one side? So think about it this, right? Would the heat from the sun constantly baking one side of the Earth, and then being frigid on the dark side of the Earth, the nighttime side, would that affect cooling in the core? And I'm still going to say no.
I'm going to say no.
No. First of all, the Earth's still spinning. So you're only heating up something for a little bit, and then you're cooling down something for a little bit. So the net over the year is still 0 as opposed to 15. So just that alone. But then, my analogy is you have a nuclear reactor that is the Earth's core. You have the atmosphere that acts like a blanket. If you put a blanket on a nuclear reactor, it's not really going to keep it warmer or colder. It's so minuscule that it's not really going to. It may mathematically over billions of years make a difference, but it's probably very, 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 very small.
Yeah, the conduction rate is so slow. The rock, and you still have the pressure, of all that.
I mean, obviously, it's cooling off. Like, something's happening. The reaction is stopping. It is cooling off. And that atmosphere is a blanket, but the blanket would be like such a minimal factor in that equation that it wouldn't make that much difference.
So what if you had like Mercury and Venus rotate really slowly?
Mm-hmm.
Venus rotates its rotation rate, so it's one day is longer than a year on Venus. It goes around the sun faster than it rotates.
Yeah, Venus is a weird one too because it's like flipped upside down.
No,
isn't There thought something might have hit Venus.
You're thinking of Uranus. Uranus is on its side. But if you have that really long, I think the orbital period of Venus is like 200 some days. If you have this temperature imbalance for 200 days, is that enough to move heat one direction or the other? I don't know, probably not.
I don't know. And when you're that close to the sun too, does, and the size of the planet, are they already, I don't know if those Mercury and Venus, are they already done? Are they cooked? They're already cool all the way down to the core. I don't know.
Well, that's really interesting. Do other planets have cores? Does the moon have a core? These are interesting questions. We need to get that drill rig up there on the moon.
That's what I'm saying.
So real fast to go back to this Venus thing. Venus, that's what I goofed it up. Venus and Uranus are spinning in different directions than the rest of the planets.
You can say Uranus.
That's
Nope.
sure.
Carry on.
Yeah.
Yes, Steve. Uranus is spinning in a different direction than everything else.
Hey,
Is that what you wanted me to say?
a little bit.
Okay.
Hey, we got to keep it lively here.
Yeah. So
You don't need to mark this down.
It's going on the dry erase board. It's going on the dry erase board.
yeah, Venus and Uranus spin east to west.
Yeah, that's what it was. I'm always fascinated by, how the nebulous theory came about in the 1700s by Immanuel Kant. And
Please elaborate on what that is.
okay, so the nebulous theory is how stars form. Stars form from a giant gas cloud, and that's basically the gas becomes concentrated in the center, and then you get the star forming, and then the planets form from accretion or going around.
Yeah. Skipped over.
Yeah,
and gas, and then the star forms, and
it's
but
just
yeah,
that
that cloud of gas is called the nebular cloud. So I should have put that one together.
yeah. So, but it's always amazing. Immanuel Kant came up with this. I think it was the later part of the 1700s. Let me look this up real fast.
Wow.
Yeah, how the hell do you figure that thing out?
That's pretty good. That is pretty good.
And nebular hypothesis. Here it is. 1755 came up with the nebular hypothesis.
Gosh.
I guess that's technically the later half.
Yeah, all right, come on. But it's like, that's amazing. Like, how does that happen? Like, that dude hit a grand slam in 1755. Nailed it out of the park. Good for him. Good for him.
There was a lot of good science coming out.
I always tell people that's what happens when you don't have Facebook or Game of Thrones to distract you. Could you imagine if we didn't have HBO right now, where science would be?
I don't have HBO.
I don't have HBO either, but I hear the shows are great.
Yeah.
I like.
Speaking of HBO, if you want to become a Patreon member.
Oh, that's a great segue for this.
Yeah, right? Come on.
All right. You want to wrap it up?
Let's do it.
All right. I'm out of. I think we covered everything that we said we wanted to cover today.
Yeah.
Yeah, I could cover 10 more things, but Chris is just going to cut it out anyway. So,
Judge, jury, and executioner right here.
Yeah, exactly. So, enjoy the future Flannelcast with just Jesse and Chris. I'll become a Patreon and make Jesse say weird things and ask.
You can start your own one and just call it the Uranus cast.
Nice. No, I'm serious. I think we should do a Flannelcast with our significant others for like 5 minutes. Just have Sarah, Brooke, and Megan just complain about the Flannelcasts. We just talk about it.
Steve, I think your podcast should be called Heads Up Uranus.
That'd be incredible.
I'm not editing that out. That's
I'm working on it now. Of course you're not editing it out. It was hysterical. When you say it, it's funny. When I say it, it's blasphemous. Anyway. All right. Well, don't forget to check out Formatting Formula for any of your Word documenting needs. Make sure you check us out on Patreon, Facebook. Apparently, we're going to be on Instagram soon.
Dornberg says so. If we're not on Instagram,
I'm pretty sure we were on Instagram, but I'm pretty sure we had a picture of like our stickers and like maybe a flannel shirt or something. So we'll revive it.
Yeah, get ready to see my rocks.
Yeah, who knew Instagram was going to stick around?
Jesse's new spinoff podcast right there.
Yeah.
Jesse, see my rocks.
All right. That just took a turn. All right. Let's see. Facebook.com/Geology Flannelcast. On Twitter @GeoFlannelcast. GeologyFlannelcast.com for our website. You can get the links from the show there. If you would like to help out, if you really like this the podcast and you'd like to help out financially, help us pay the bills, help us upgrade with some equipment stuff that we drastically need to get to take our podcast. It's just going to take our podcast to the next level. Right?
Yeah, exactly.
Let's just say green screens, and let's leave it at that. All right.
Cats in space.
Anyways, no, but if you would like to help out the podcast, you can check out our Patreon page at patreon.com/Geology Flannelcast. Thank you to all the Patreon sponsors already. Thank you so much. You guys are helping us out a ton. And
yeah, some of the Patreon levels, we actually post extra stuff, like all the funny times that I was during the podcast that Chris cut out might be posted.
Yeah, I think we should talk about that more. So if you are, we have different tiers set up, but if you're on what we call the quartz tier, you can see we after every show we try to post a couple of minutes extra. If we're interviewing someone, we have an extra, like, I don't know, it varies between 15 and 30 minutes or so of just extra questions, a little more laid back atmosphere. But we have some fun questions for our guests, or sometimes we'll just kind of go off on just kind of extra news stories that we don't put on air. But so there is extra material if you become a Patreon member or a Patreon sponsor. There is extra stuff up there on that site. So
yeah, and if you're a Patreon member, keep pushing Chris. Be like, just post the unedited stuff.
You really want to learn about chaos theory?
No, actually, the unedited stuff is Chris does a great job editing this stuff.
Yeah.
He really does. So I'm just busting his chops at the moment.
So don't forget to check out the formatting formula. If you any issues with formatting any Microsoft Word documents, check them out, or check out their YouTube site too. They have tutorials on there too. youtube.com/c/formatting formula. So that's it for today, guys. Thank you so much to our listeners. We love you guys. Thank you so much for listening. We couldn't do this without our listeners. And send us, keep on sending us your emails. Hit us up on Facebook. And yeah, we're going to do that. The contest, I don't know. We'll keep it open for. I'll post something on Facebook, but we'll do that. Send us your favorite picture of a rock.
We'll keep that open
collection
for a couple weeks, maybe the summer or something like that. Yeah.
Yeah. Well, I don't know. We'll have some fun with this thing. We'll have some fun. So yeah. So hit us up. Send them over on Facebook or on our Twitter. Tweet us the pictures, and that'll be fun. So all right, guys. I'm out of things to say. Any of you gentlemen have anything else to say?
No, thanks for listening.
Yeah.
Thanks for listening.
Thanks. I appreciate everyone.
All right. Cue the outro music right now. And I'll see you guys later. Thanks. Bye.
Yeah.
Bye.